For this question, we want to solve the exponential equation 3.14 to the x equals pi to the 1 minus 4x. So most of you know that pi is approximately 3.14. And that means that these two sides of the equation have almost the same base. So I'm going to write that down. Almost the same base. Now that is important because one of our methods for solving exponential equations is the relating the bases method. And in that method, we try to make the bases the same on both sides. So I'm going to use that relating the bases method on this example. But we have to know, since these bases are not exactly the same, they are almost the same, but since they're not exactly the same, our answer will be an estimate or an approximation. Our answer will not be the exact answer. So I am going to solve it with that relating the bases method, but we'll write it down and we'll keep in mind that our answer is going to be an approximation. So these bases are pretty close to each other. So we're going to use that property, that one-to-one property, and say that the exponents are equal to each other. X is equal to 1 minus 4x. And we're going to solve by adding 4x to both sides. That gives 5x equals 1, and then I can divide both sides by 5. That gives me 1/5, which is 0.2. So this is a good approximation, but it is not the exact answer. If you need to be more accurate than 1 decimal place, then you need to do this with the other methods that we've learned. And my math lab is going to ask you to be more accurate than just 1 decimal place. So you need to do it in the ways I'm going to show you now. So I'm going to show you with the method of taking the log of both sides. We start off with 3.14 to the x equals pi to the 1 minus 4x. The method is to take the log of both sides. We're going to do natural log on the left and natural log on the right. On both sides, we have logs and we have exponents. So that means that we're able to use the power rule. The power rule for logarithms allows me to move that exponent to become the coefficient of the log. So this becomes x natural log of 3.14 equals 1 minus 4x natural log of pi. On the right-hand side, I'm going to use the distributive property, and that's going to give natural log of pi minus 4x natural log of pi. I carry down the left-hand side, and now I want to start collecting the x's. I have an x here and an x here. When you collect the x's, you want them on the same side, so I'm going to move this x term to the left-hand side. You want to collect the x's on one side and everything else on the other side. So this term does not have x. I'm going to leave it on the right-hand side of the equation. So we have x natural log of 3.14 minus, I know that'll be a plus, 4x natural log of pi equals natural log of pi. Now that I've collected the x's, I want to factor the x out, and that will leave me with natural log of 3.14 plus 4 natural log of pi equals natural log of pi. And finally, I can get x by itself by dividing by the parentheses on both sides. So I'm dividing both sides by natural log of 3.14 plus 4 natural log of pi. So I've got my final answer, x equals natural log of pi over natural log of 3.14 plus 4 natural log of pi. I'm going to type this in my calculator, and we should get something really close to 0.2 because we said earlier that that was an approximation of our answer. So let's see. Got natural log, and where's pi? Pi is right here. So I'll hit second and the caret key to get pi. Divided by, and I need parentheses around my denominator. Parentheses natural log of 3.14, close parentheses for that log, plus 4 natural log of pi, close parenthesis for the log, and close parenthesis for the denominator. And you can see here we have 0.20001777205. So if you need to be accurate to 1, 2, 3, that's the fourth 5 decimal places, you would get your answer wrong by using the other method. But you do see that they are very close to each other. On this example, we're doing an application of our quadratic functions. And I'll read through the problem with you, but you'll notice that we have maximum, maximize, and in our quadratic applications, we can find the maximum at the vertex. But we're going to have to build our functions before we do that process of finding the vertex. So let's go through the details here. Silver Scooter Incorporated finds that it costs $200 to produce each motorized scooter, and that the fixed costs are $1,500. The price given by P equals 400 minus X, where P is the price in dollars at which exactly X scooters will be sold. Find the quantity of scooters that the company should produce and the price it should charge to maximize the profit. Find the maximum profit. So this example is a business application, and it requires you to know some formulas. And let me go over a few of the formulas. So you'll notice here that we want to maximize profit. Now profit, the business formula of profit, can be found by doing revenue minus cost. So this gives us some of the information that we need. I know that I need to find the revenue function, and I need to find the cost function in order to find the profit function. Now, the revenue function can be found by doing X times P, where X is the number of units and P is the price. Now the cost is more complicated. There are more things involved in figuring out the cost function, but our problem describes the cost in detail for us. So we're going to use the information given in the problem to find the cost. Once we get that revenue and cost, we will subtract them to get the profit. Okay, so let's start by finding the revenue function. Revenue is going to be X times P, where P is the price. Now we do have to be a little careful here because we have a capital P for profit and a lowercase p for price. This is the lowercase p for price. So I'm going to highlight the sentence we're going to use. The price is given by P equals 400 minus X, where P is the price. So our revenue function is X times 400 minus X. That's 400X minus X squared. That's our revenue function. Our cost function, so I highlighted what we needed for revenue. Let's highlight what we need for cost. It costs $200 to produce each scooter, and there's a fixed cost of $1,500. So we have a variable cost of 200X. It costs $200 per unit. X is the number of units, plus $1,500. That's our fixed cost. So our cost is 200X plus 1,500. Now with this information, we can get the profit. Profit is revenue minus cost. Let's do it down here. Profit is revenue, which is 400X minus X squared, minus cost, so minus 200X plus 1,500. I'm going to distribute that minus. That's 400X minus X squared minus 200X minus 1,500. So we have a profit function, if I combine like terms, negative X squared plus 200X, 400X minus 200X is 200X minus 1,500. So this is our profit function. Our profit function is a quadratic. You'll notice it's a quadratic with a negative leading coefficient. And because of that, the graph is going to be a parabola that's down facing. Remember, we're looking for the maximum. The maximum will be the highest value of the profit, and that maximum is at the vertex. So we want to find the vertex in order to find the maximum profit. We have a vertex formula. The vertex is HK. The formula for the vertex, or the H, which is the x-coordinate of the vertex, is negative b over 2a. It's negative 200 over 2 times negative 1. That's negative 200 over negative 2. And that is 100. Then we can find K by substituting 100 into the profit function. So 100 into the profit function will be negative 100 squared plus 200 times 100. minus 1,500. And I'll use my calculator to work that out. Got negative 100 squared plus 200 times 100 minus 1,500. We get 8,500. So we are going to have a maximum profit of 8,500 by producing and selling 100, what are we selling? I don't even remember. Scooters. Now we do have one more thing that we need to answer here. I'll highlight it for you. I'll highlight all the questions for you. So here it says, find the quantity of the scooters to maximize the profit. The quantity of the scooters is 100. It also says to find the maximum profit, and 8,500 is the maximum profit. And the last thing that we need to do is to find the price that should be charged. So for the price that should be charged, we're going to use this right here. Remember, the lowercase p stands for price. The lowercase p for price is 400 minus x. That's 400 minus 100, $300. So we should charge $300 per scooter to get a maximum profit of $8,500, and we expect to sell 100 scooters at that price. So on this example, we want to use the product rule to expand the logarithmic expression. Whenever possible, evaluate the logarithmic expressions. The expression that we're trying to expand is log base 6 of 1 over 216x. So before we start working on this, let's write down what the product rule is. So the product rule for logarithms looks like this: log base b of m times n equals log base b of m plus log base b of n. So it's called product rule because we have a product inside the logarithm. And when you have a product, you want to expand with addition. Inside each log, you can see each factor. So in our example, I'm looking for places that I can use the product rule because it's got in the directions that I need to use the product rule. So in here, I have 1 over 216 x, which means 1 over 216 times x. So I've got a product right here. I'm going to use the product rule. I'm going to write log base 6 of 1 over 216 plus log base 6 of x. We expanded with addition because we had the product inside the log. If we have division instead of multiplication, we use subtraction when we expand. That's called the quotient rule. Now we have expanded using the product rule, but this second sentence here says, whenever possible, evaluate the logarithmic expression. So this first log is log of a number, and I want to try to simplify that. So I'm looking at the base, and I have a base of 6, and I'll look at powers of 6. 6 to the first power is 6. 6 to the second power is 36. And 6 to the third power is 216. Now I have 1 over 216. Having a fraction like that is the reciprocal. So 6 to the negative 3 is 1 over 216. So I'll simplify that log expression to be negative 3. Log base 6 of 1 over 216 is negative 3. So my final expansion of the expression log base 6 of 1 over 216x, it's negative 3 plus log base 6 of x. So I want to continue with this example for a second here because this is not the only way you can do this problem. So these directions specifically ask to use the product rule. But if we also use the quotient rule here, we can take log base 6 of 1 over 216x, and we can expand it using the product rule and the quotient rule. And if we use both of them, it would look like this. Log base 6 of 1 minus log base 6 of 216 plus log base 6 of x. So we used the quotient rule because we had a quotient here, and that's why we have a minus right here. The 1 is in the numerator, so that log is positive. The x is in the numerator, so that log is positive. But the 216, that log is negative because 216 is in the denominator. Then both this log and this log are log of numbers, so we want to try to simplify them. So 6 to the 0 power is 1. Log base 6 of 1 is going to be 0. Log base 6 of 216 is 3, using this one right here, plus log base 6 of x. 0 minus 3 is negative 3. And we get the same answer with a slightly different approach. So we get our answer of negative 3 plus log base 6 of x.
Thank you for checking out my videos. Have a great day.